Hey guys! So today we're going to be looking at something converges or diverges, and we have this. This is our complete question, and we know here that we'd be using a ratio test instead of a root test because we have something to the n, something to the n. We do have no factorials, so it could be a little misleading. Because usually with factorial, it's kind of a good thing for the ratio test. Now, the thing is that we wouldn't be able to do a root test for this because it's not all to the n. If it was all to the n, we could do that and that would be no problem. So that's why we come here and we have our limit of a to n plus 1 all over a to the n, right? Right. But then we can just, all I did here is I flipped the fraction right here, and so that it look like more like I'm multiplying than dividing. If that's confusing to you at all, go ahead and work it out. Start with just dividing a of n, and then you'll see how I multiply it over. From there, we know that all of this is positive, right? So let's just put a positive here. Let's make it a little easier on ourselves. And this right here, a little trick, I did 3n plus 4. And that is because you can't just do 3n plus 2, like a 3n plus 1 plus 1, because the 3 is multiplied by then. So it's 3n plus 1, you have to put in parentheses, plus a 1. So this was in the original equation, right? And we had to do n plus 1, so that means it turns into 3n plus 4, which is this. It's a big mistake, so definitely something you'll be tested on. And if you're not, then that's crazy. So, okay, just kidding. It's called sarcasm. So, okay, so after that, I can simplify this to do limit n going to infinity, and we can. It turns into 12, right? Because this is 12n minus 1. And the same as if you have a 12n minus 1, it's the same as 12 to the n times 12 to the negative 1. That's only when you add them, though. If you multiply them, then it's something then to the power of something. So, you put 12 on top. You have, this is the same as like a 3 to the 3n times a 3 to the 4th. This is the same as 3 to the 3n times 3. So, you know that can just turn 3 cubed, which is 27, right? So, and then you have an n squared up here, and n plus 1 squared. So you know that this ends up turning into 12 over 27. And to simplify this, you can kind of say that the limit is kind of approximately equal just to 12n squared over 27n squared. Because this 9 plus all the other factors of it, it's not what it wants to go to. It wants to go to the largest polynomial possible, which is n squared. That's why we can do this simplifying. Never forget your limits. Really do nice notation. I just have a small amount of room. And then you know that this can go to 12 over 27, which is going to be less than 1, and that means it converges. So we know then that it converges by the ratio test, and that's it.